Alrighty, so this is our Exam 1 review. Our first exam is coming up, and I want to go through what topics to expect on the test, what would the test look like, things like this, just so you can be prepared as best as you can to do well on the test. So the test is going to be very similar to what the homework looks like, in that I'll give you a circuit or a series of circuits, and for each circuit I will either ask you for the total resistance or the total current, or I will have one of the little tables where for every resistor in the circuit I want you to tell me what the current is and what the voltage dropped is for that resistor. So if you've done the homework problems or you've done practice problems, then you've seen what the questions will look like. Of course, the circuits may be different, they may be different arrangements. They're not going to be identical circuits to what you've already done, but they're going to be of the same basic nature. So, what topics have we covered thus far? Obviously, there won't be any questions on just what we did for the math review. That was just background review so that we will be prepared for actually calculating what we need to calculate for these circuits. The first big topic we discussed was resistance. And for this, we had circuits with some number of resistors in them, and it could either be in series or in parallel, or a combination of the two, and you had to combine those resistors together one at a time to get some total resistance for the whole circuit. And so in order to do so, you had to know which is in series, which is in parallel, and once you know that, how do you add the resistors together in series or in parallel? And so, of course, for series, the resistance of a series set of resistors is just the sum of each individual resistor. So you just add up all the resistors that are in series, and you get the total resistance. In parallel, it was a little more complicated. What you added here was the inverses. So we had 1 over R parallel is 1 over R1 plus 1 over R2 plus 1 over R3, and so on. And of course, for this, it was very important that even if you add them up correctly, you add the inverses together, what you get is not the parallel resistance, but 1 over the parallel resistance. So you had to take the inverse of that final answer. That's what this part right here says. So that was the first topic. Can you combine resistors in series and parallel to get a total resistance for your circuit? Once we were sufficient with that, we went on to Ohm's Law. And with Ohm's Law, we were given a circuit, and the same basic question, only this time I want to know what's the current running through the circuit. And so in order to do this, of course, we still had to be able to do what we did in the last section, finding the total resistance, but once we knew it, we would use Ohm's Law, which is V is equal to I times R, where V is the voltage, I is the current, and R is the resistance. And so if we put the total voltage of the circuit, whatever the voltage source says, and the total resistance of the circuit, whatever we found by combining them in series and parallel, then the current we would calculate would be the total current. So I is V over R and whatnot. And so that was Ohm's Law style of problems. And in fact, we went even further by not just knowing total voltage, total current, total resistance type stuff, but then we also did V equals IR for individual pieces. You know, what's the current running through the first resistor, or the 3 ohm resistor, or what's the voltage dropped by the 4 ohm resistor. And for this, the questions were set up where we have this table like this. You're given some set of resistors, and you need to fill in the current and the voltage drop for each resistor. And in doing so, we had a few rules that we had to remember. And the rules dealt with, if the resistors are combined in series, then all the resistors that are in series with each other feel the same current. They will have the same I. And likewise, if you have a set of resistors in series, then the voltage dropped by each resistor would be different. So if you have a 2 ohm resistor, it's going to drop a different voltage than a 4 ohm resistor if they're in series with each other. Because remember, you're doing V equals IR. They all have the same I, but if they have different R's, then you're going to have different V's, obviously. The other set of rules dealt with the parallel situation. If you have resistors in parallel, then each branch of that parallel set will feel the same voltage. So they'll drop the same voltage if they're in parallel. But each branch will have a different current. Because when the current comes in and it hits a parallel set, it has an option of which way the current wants to flow. And the current will always flow in a way such that more current will go through a branch with less resistance than will flow through a branch with more resistance. It's easier to flow through less resistance, so you'll have more current in that branch than a different branch that has a higher resistance. So parallel resistors have different currents, but they have the same voltages. And so knowing those rules, then we could start filling out these tables for finding out the current in each and the voltage in each. The last topic we have done is loop analysis. And with this topic, this was a more advanced way of analyzing a circuit. And here, you would have some circuit. Usually it has more than one voltage source, but it doesn't have to. But it will have likely more than one loop of the circuit. So, something like this. Here's an example where there's 2 loops in this circuit. There's only one voltage source, but we could still do loop analysis. And what you would do is you would say, okay, this loop here has some current called I1. This loop here has some current called I2. And once we know that, then we set up an equation. Loop 1's equation will be V plus, some I times R1 plus I R2 and so forth equals 0. Actually, those aren't pluses, those are minuses. I'm sorry. Remember, when the current hits a voltage source, if it hits the small side then the big side, it's adding, so it's plus V. If it hits the big side then the small side, it's subtracting, minus V. But every time the current hits a resistor, it's always minus. Minus I times R, where I is whatever current is hitting that resistor. And then, of course, for a resistor like this one here, that's in the middle of 2 loops, the I that hits him, well, there's I1 and I2 are both hitting him. So we have to add these currents together. Now, technically speaking, it's either adding or subtracting, and it depends on the directionality of the currents. If both currents are moving in the same direction when they hit the resistor, then they would add together. If they move in opposite directions, they would subtract. So if we look at this one, I1 is coming down this way, whereas I2 is coming around this way. They're moving in opposite directions, so you'd be subtracting them, I1 minus I2. And so you would set up an equation for loop 1, and you do another one for loop 2, very similarly. And then once you have the two, or however many equations you have, you would then solve those equations for the i's, I1, I2, I3, however many i's there are in this problem. You calculate the I. Usually it's going to be, two equations with two unknowns, or three equations, three unknowns. And so you have to find some way of solving a system like that. You could do the basic algebraic way of doing it, which is substitution method. Or I also showed how to use Cramer's rule with matrices. And that's a different way of being able to solve them. But however you want to solve them, you're going to solve for all the i's. Once you solve for all the i's, then again, there's going to be a table sitting there. And it's going to say, okay, for each one of these resistors, tell me the I and the V involved. Okay. Just like Ohm's Law, only in order to find it, you had to use loop analysis instead of Ohm's Law. So these were the three big topics. All the problems on this test are going to come from these topics. I have not yet made the test, so I can't tell you exactly how it's going to be. But, expect the test to be of a length that can be completed in an hour. Even though this is technically going to be a take-home test, and so I'll give you the full day to work on it. I'll post it in the morning on Canvas. You download it, just like is done for homework assignments. You download the test, you work it out, and then you submit it back to Canvas by 11:59 p.m. of that day. You'll have the full day to work on it. So, although the university wants me to, when I do tests like this, they should be synchronous, so they should be done during class time and all of that. I know that everybody's different. Not everybody is free or available at this time. You may be in a car, you may be at work, you may not have the ability to take the test during the class time, so I'm going to give the whole day to do it. That doesn't mean it's going to take the whole day. It's going to be a 1-hour test. If you want to take longer than an hour to work it, that's up to you. But this is of the same size as I would generally give in a normal in-class type course. I think everybody in this course has had me in a class before, so you know what my tests look like in general. Nothing new, nothing crazy. I'll give you a lot of room to work everything. You work out all the problems, show your work, box your answers, or if it's the table, you put the answers into the table as shown. But that's the way the test is going to work out. How should you study? Best way to study, in my opinion, is number one, go back and work the homework problems that have been posted. After you've done that, if you still have more time to study, work all the practice problems that are on Canvas. I've posted practice problems with their solutions for these topics, so you should be able to go back, get a blank sheet of paper in front of you, and work the problems as if it's a test. If you could work the problems and get them right without looking at the answers, or without using your notes, then you know you're good. There's no way you're going to be able to work the practice problems and get them right and then do poorly on this test. If you legitimately work the practice problems and you understand how to do them correctly, the test is going to be of the same nature. So I would expect you to get 100 if that's the case. If there are any you're unsure about or you're not getting right, go back to the solutions and look what I did. And if you still have questions, of course, you're more than welcome to email me. If I can answer the questions through email, that's what I'll do. If not, and you want to talk more in person, then we could set up a Zoom meeting appointment to discuss some of the problems and see what's going on. Obviously, you can also look at the videos. The videos I would concentrate on as it pertains to studying for the test are the ones with example problems. So watch the example videos first, because you watch me actually solving problems The same types of problems you're going to see on the test. I talk my way through how to solve them. So that's the best way for you to be able to get a good idea of what's expected of you for the test. What resources can you use for this test? Anything you want. You could use any resource except for one, which I'll discuss, but you're welcome to use your notes, you're welcome to look at the homework, you're welcome to look at the practice problems. Whatever you want to help you solve the problems is perfectly fine with me. I'm not going to be there on your computer watching you take the test, so I can't stop you from using solutions or things like that. And so I won't even try. The only thing I do ask legitimately is that you not work with other people to solve the test. Do not copy, do not text someone else, do not call them on the phone, get on Zoom, any of that stuff to work on a test together. This is an independent test. Everybody should work on it on their own and give it a legitimate try. The last thing I want to see is some set of tests where everybody did the question exactly the same way, and it's obvious that people copied off of each other. It's very easy to spot it. You're not tricking anybody when you do that kind of stuff. Professors see that you're doing it. And so I try to be as lax as I can when I give these tests and I give practice problems and homeworks and stuff. All I ask in return is that you respect the fact that this is your test, and I want to see how you're doing on the test. I don't want to see how your friend's doing. So work the test yourself. Don't copy. Don't ask others for answers or any of that. Use whatever materials you have at your disposal from the course to help you along solving them. Just don't copy off of someone else. That's all I ask. So, I believe that's all I have for this review. There are practice problems and such posted for all of the different topics. Go back, or example problems videos posted. Go back and watch them. And like I said, if you do have any questions, you're unsure about any of these topics, or you just want to make sure you're doing something right, email me and I'll do my best to help out. But definitely don't wait for the day of the test or anything like that, because likely that's when the majority of people are going to ask, and I may not have time to answer everybody's questions. So if you ask me early, like this weekend, then you're more likely to get your question answered before you actually take the test than if you wait till the end. Also, that reminds me, when it comes to submitting the test, the deadline is 11:59 p.m. of the day of the test. However, my suggestion, as is true for homework, is that you try to have it submitted before then. And I don't just mean submit it at 11:50. What I mean is try to submit it at 2 in the afternoon or 3 in the afternoon if you have the ability to, because if there's some technical issue where Canvas isn't accepting the submission, you will have time to email me and let me know, and we could work something out about that before the deadline passes. If not, then when you email me that, oh, I couldn't get it submitted in time for whatever reason, I'm just going to assume it's because you did it late and you didn't actually turn it in on time. How do I know if what you're saying is true? If, however, you tell me at 2 in the afternoon that there was an issue submitting it, but you have it done and here's proof, then I have no reason to doubt what you're saying. So do your best to try to get it done early and submitted. That way there's no doubts about late submissions of tests and things like that. All right, so that's all I have for this. I wish you luck with the studies, and I will see you next time.